Okay, so we would like to compute a double integral, which is defined over a domain which is not a rectangle. And let us give a general formula for such integral, at least when the domain is defined by two functions, by two graphs of functions of x. So let's say we have the lower graph, which is y equals g1 of x. We have the upper graph, which is y equals g2 of x. We have the left point A, the right point B, and this is the domain D, which can also be described as all xy's, for which y is between g1 of x and g2 of x, and x is between A and B. Okay, so if we have such a domain and we wish to compute the integral of a function f of xy, then this can be written as an iterated integral. We do first vertical integration, meaning we integrate over vertical segments of varying endpoints. So they go from g1 of x to g2 of x. And the way we can understand this is that for a given x, we integrate over exactly this segment, whose endpoints are the numbers that we just put the outputs of the functions g1 and g2. And then we do horizontal integration over the interval AB. So that's precisely the formula that we're going to use. So let's proceed with the solution now. So we have the point 1, 0. We have the point 0, 1. This is the domain D. Actually, in the statement of the problem, we might have said that it's the solid triangle, but since we're talking about double integrals, it should go without saying. And or a triangle including its interior, we can use any of these expressions. But the most important thing here is to know what this line segment, how it can be described, and the equation of intercepts for this one is x plus y is equal to 1. So this makes the lower boundary will be y equals 0, and the upper boundary will be y equals 1 minus x. And we will do vertical integration first. So this means that we will have the integral from 0 to 1 minus x. The integrand was x plus y squared. Dy first, since we do vertical integration, and then integral from 0 to 1 dx. So that's how we write our integral as an iterated integral, our double integral as an iterated integral. And now we differentiate, we integrate first with respect to y. So that will give us xy plus y cubed over 3. And this will go from y equals 0 to y equals 1 minus x. And then we have to integrate this with respect to x. So this will give us x times 1 minus x plus 1 minus x to the third over 3 minus 0 if you like. And we have to take this integral from 0 to 1 dx. So let's use the crudest method here by just foiling everything. So we will have x minus x squared plus 1/3 times 1 minus 3x plus 3x squared minus x cubed dx. So this will be the integral from 0 to 1. And let's start with the minus x cubed over 3. What squares do we have? We have x squared minus x squared. So actually, this cancels with that because remember there's this 1/3 in front. So this becomes x squared minus x squared. And then we have minus x, again, because of the 1/3 in front. And plus x, this cancels with that. And eventually we have plus 1/3. So overall, a very pleasant computation. And now we will have negative x to the 4th over 12 will be the antiderivative of the first summand and 1/3 x of the second summand. We go from 0 to 1, and of course this is negative 1 over 12 plus 1/3. 1/3 is the same thing as 4 over 12. And this will be eventually 3 over 12, or also known as 1/4. And that's it. I mean, here we should emphasize that the most important step in the whole process is actually to reach this point, meaning to write our double integral as a double iterated integral. After that, everything is pretty much straightforward. And that's all. Thanks for watching.